This is a clip with only one question, asked to today's physicists. Of course, you are welcome to ask questions and do so in the comment section. I am one of the physicists. ChatGPT is amongst the many sources I've interacted with in the past. The question is, what is still wrong in physics and holds us back? The physicist says, in everyday physics and the lives of physicists, nothing is wrong. We know we work with approximations in our experiments and we just have to live with it. We trust mathematics and the mathematicians in doing the great job of being the exact part of our work. In the details, we still have some models that do not match up. Specifically, our models for the great and the small do not unify. But we have programs like string theory and loop quantum gravity to tackle that problem. We will figure this out with proper financing. ChatGPT produces. In physics, despite significant progress over the years, there are still several unresolved questions and challenges that continue to hold us back from achieving a complete understanding of the universe. Some of these outstanding issues include quantum gravity, dark matter and dark energy, cosmic inflation, grand unified theory, emergent phenomena, and foundations of quantum mechanics. Addressing these challenges requires interdisciplinary collaboration, innovative theoretical frameworks, and experimental breakthroughs. While these issues may present obstacles to our current understanding, they also represent exciting opportunities for discovery and advancement in the field of physics. My answer? I agree with all of the above, but the illusion of the exactness of mathematics gives it an air of invincibility that it doesn't have. Mathematicians and physicists unfortunately like this air and the social status and position that come with it. Their first reaction is to embrace this air and ignore coming change. The strength of mathematics does not lie in mathematics' invincibility, but in the fact that it is our best, most logical tool for describing reality from our point of view and abstracting and generalizing from there. No more, no less. Mathematics describes, physics explains, philosophy understands and believes. Take a foundational definition in mathematics, and the relation with reality is immediately clear. Try negating the definition and using that to build mathematics upon, if you are not convinced. We use useful and relatable objects in mathematics, like numbers. Obviously, since Kurt Gödel, we have the incompleteness theorems, but this is a resulting issue. I would argue that there is an even bigger issue that begins with beginning to distinguish, and the consequences that arise from distinguishing. For instance, the incompleteness theorems follow from the mere fact of distinguishing a 1 from a 0. Self-reference, paradoxes, and intuitions of unreachability, infinities and continuity are possible because distinctions come before. There is no inconsistency in the fabric of reality. From this, we can already see mathematics does not deserve the air of invincibility, and certainly not the air that reality is made of it. Here's to helping break down the air of invincibility and building better air by exposing some weaknesses in mathematics and physics that we do not normally acknowledge. First, on mathematical definitions. We have definitions for the concepts number, infinity and continuity, that are not correct yet. They just seem correct and are useful enough for good enough approximation. We therefore think we have the distinction between continuous mathematics and discrete mathematics, while in reality we only have discrete mathematics. An acknowledgement of our inability, where continuity is concerned, is needed in the shape of a new object in mathematics, a continube or in-between or whatever we want to call it. If we do not acknowledge this shortcoming in mathematics, there is, for instance, the risk of drawing the false conclusion that reality is discrete because our mathematics is discrete. It seems that this premature discrete reality conclusion, or at least suggestion of it, is already becoming popular these days. Second, on complete machinery in physics. We do not recognize the absence of complete machinery in physics. There is a clear hunger for adding more and more machinery to the existing mechanisms, but without realizing the necessity of complete machinery. Mathematical singularities in black holes scream for a proper complete machinery treatment. Singularities should be removed from physics as soon as possible. They are mathematical artifacts, fueled by the lack of material description. Third, on more specific complete machinery. We need complete machinery for fermionic behavior, not only mathematical symmetry tricks using matrices and spinners, and visual illustrations using belts and Balinese dancers. Where does half-integer spin behavior come from? What is it made of? We need complete machinery for the concept of entanglement and quantum mechanical behavior in general. We should not take the sentence that reality is quantum mechanical too seriously. There is a reason for this behavior, based in a material and complete machinery description. We need complete machinery for phenomena such as dark matter and dark energy. Again, not stop at mathematical symmetry tricks using our particle or quantum field view, but conceptual, complete machinery with objects and properties. We need not just physics, laws, and tensor fields of numbers, somehow in a space-time, may be inferred from some invisible properties. But what is dark matter? What is it made of? What produces the tensor fields of numbers? The answers are not mathematical. The answers should be conceptual physics and machinery-based. Mathematics takes over for detailed description. Fourth, on reality versus perspectives on reality. We need to model reality separate from our human or measurement apparatus perspective, separate from our scientific method perspective. Or, in other words, we need to separate the description of reality from the description of reality by measurement apparatus perspective and its perceived distinctions. Nature probably doesn't hold or need those distinctions in its machinery, and yet is capable of facilitating perspectives on these distinctions.